So good evening, everyone, and welcome to OTF Connects, April 11, 2017. We've had a dynamic year of OTF Connects, and we're into the last few weeks now. So we're happy to have you all here, so a warm welcome. And I'm really excited to introduce Scott McKenzie to all of you. Scott and I are colleagues in the Waterloo region, have known each other for quite a few years, and I've been a fan of the great work that Scott's been doing in his grade 3 classroom, introducing his students to coding and to using coding in Minecraft and many of these tools in really powerful ways to support their learning and to enhance their learning. So we're excited that he's joined the OTF Connect program this year. This is his second webinar, I believe, and I'm going to turn things over to Scott. Welcome, Scott.
Good evening. Thank you very much. Thanks for that nice introduction. Good evening, everyone. I hope you're having a good evening. It's cleared up here in Kitchener-Waterloo area, so that's kind of nice. It was raining pretty hard earlier. My name is Scott McKenzie. I teach grade 3 currently. I'm generally in the grade 3, grade 4 range, although I have taught as low as grade 1 and as high as grade 6. I'm here tonight to talk to you about mathematics and also to talk to you about how Minecraft can be a very powerful and useful tool in your mathematics program. I am not a Minecraft expert by any means. I would say that my 8-year-old daughter and my 7-year-old son are better experts than I am, but I learn as I go with the students, and I've been doing that for a few years now. So there's a lot of things I've noticed that I've found, and I think that in your classrooms, for most people, you'll find your students are great fountains of knowledge when it comes to Minecraft. A lot of them really, really love it. So yeah, that's my Twitter handle, ScottMcKenzie27. So follow along if you want on Twitter. I'll do my best to check in there as well tonight. What I'm going to start talking about first is just how Minecraft has became something that I used in my class. So if you want more information about Minecraft and you're looking for how to go deeper, a great resource in our province is gamingedus.com. This is a place where some teachers that are in the Toronto area and the Hamilton area have set up a lot of information. Liam O'Donnell, Diana, Denise, Jen, and Andrew Forgrave, they have put a ton of resources together there, and I would recommend that as a place to get information about doing things with Minecraft and other gaming platforms in the classroom. Also, if you want official information about the Minecraft Education Edition, if you go to the link that's posted there, that will give you a lot of information you can read up on, and there's a lot of resources as well. And what I'll be talking about specifically tonight is Minecraft Pocket Edition. Having said that, you're able to do anything that we're doing with that tonight on the computer edition or on any of the gaming systems as well. It's available on the PS4 and the Xbox 360 and all the different systems. The first time that I thought of using Minecraft in my classroom was in 2014, so just a few years ago. And I had a class where students were struggling, and they were a couple of students in the class that had real issues with reading and writing. And often if they wrote letters, the letters would be backwards. They had a lot of trouble looking up at the board and writing things down. And I knew they were having trouble in class and that they could do more than they were able to show. And the one day, one of the students came up to me. He had his iPod at school. We bring our devices to school in my class. And he said, "Can I show this in Minecraft? Can I just, the work we're doing right now, can I just put this together and show it to you?" And I said, "Okay, let's see what it looks like and how long it takes you." And I was worried that that would take him twice as long as everyone else who was writing it down. But he was done just as quick as the rest of the other students in the class. And what he did was he built all the letters, and basically they're three-dimensional. It's on a 2D screen, but it's a three-dimensional world. And he built the letters in 3 dimensions. Not a single letter was backwards, and he put all the words together. He had no issues doing it, and added all the extra information showing it in Minecraft and the extra ways that students can do that. And he shared it with the entire class by plugging his device into the projector and sharing in front of the classroom. So that was when I was pretty excited about just the potential, and it opened my eyes to it as a tool that could be used in the classroom. After doing that, we used it that year. We did social studies, so they were building the different communities that people lived in. They did the provinces of Canada, so they were able to share all the information in Minecraft. There was a lot of neat things that they did, but I found there was a lot of value in sometimes dipping into Minecraft for the mathematics that we were learning in class. And that's one of the most powerful ways I found Minecraft was useful in my classroom at my grade level. The students did a project 2 years ago now, and in this project they joined with a class in another country and they worked together to create a digital book. And so they used Minecraft again for this concept, and everything that they did in Minecraft, and then they took it into the images into Book Creator on the iPads, and they actually wrote the story, put the pages together, and we uploaded it to iTunes as a book that all the students could share. And they did it on human rights, and it was just really neat. They built a human rights world, and it was really neat to see all the ideas they put together. Because they were working on the server, the students could work together even though they were in different places. Yes, Heather, in grade 3-4. It was a grade 3-4 class. Hence the spelling mistake on the page there. So a lot of times people will ask me things like, why Minecraft? Like, there's other virtual tools you can use online. They're easy to access. And I don't disagree with that. There are other virtual tools online. They are easy to use. But there's something to be said for going to a student's level to things that they're comfortable with and that they enjoy, and then taking what they love and using that, leveraging that to help them understand things that we want them to learn. So the nice thing about Minecraft is it's anything you want it to be. It's kind of like a giant Lego set, except you never run out of blocks. So no matter how much space you need, especially with the newer editions, the worlds are so much bigger, you don't run out of space to work, and you have in Creative, which we would use, you never run out of blocks that you can use either. So you have unlimited resources. It's something that is familiar to almost all the students in class. If they're not familiar with it, then they still know other people or brothers or sisters who use it, and they're very quick to jump in and try it because it's something that if they haven't tried it, they usually want to. The math concepts that we are sometimes asking students to think about can be quite challenging. So by giving them a familiar tool, it helps them to feel more confident when they're dipping in. There are some drawbacks to Minecraft. It's not the best tool for everything you would want to do. Often you're limited simply by the fact that it's all with square blocks. So it's not easy to make something like a triangle, but you can still talk about the idea of triangles. So I have a short video. If you're already familiar with Minecraft, I apologize for this. This video is for people who are not used to using Minecraft at all. And it's a short video, but it's one that will just walk you through how to set it up on the Pocket Edition, on an iPad, or on an Android tablet. Also on a phone as well, or an iPod. In addition to that, if you were to do it on the computer, it's the exact same setup. It looks slightly different, but it's the same setup. So this video, if we could put the link, oh, we've got the link in. Thank you very much, Susan. This is about a 6-minute video. So if you want to watch the video, and then please meet us back here, and in the chat, when you've seen the video, if you could please give a thumbs up, and just any comments or thoughts about the video after you've watched it, about what the video's talking about. Thank you. Just a reminder as you come back to please put a green check mark so that we can see that you've watched the video and we can move on. Thank you. If you have any thoughts about the video or just how setting it up works, or any questions, you can put those in the chat. Okay, the check mark should be just under your name or beside. Under. If you look just under your name, but I can see that you've watched the video. Susan, should I move on?
I would say so. We've got a good chunk of people that are finished, so the others are probably close.
Sounds good. Thank you. Okay. So that video is meant to be something that students can watch as well. So not just set up for adults, but set up for students as well. So you could literally watch it with your class and have the students discuss why they shouldn't use too many of the packs, why they should make the world flat, why they need to keep it on like creative, so if they don't, you end up with monsters wandering around, they get attacked by spiders. These are the things that take away from the value of the game. Although I have had students in the past when they're, the early settlers, if they're thinking about how the pioneers were trying to survive, a zombie isn't the same as a mountain lion or as a bear, but it does give the idea of surviving because they can build a working farm. They can create a place to keep the animals and have things growing. There's a lot of really neat things they can do with Minecraft, so there are times when it is valuable to do that. This is a quote that's always stood out to me. Play is the highest level of research, Albert Einstein. And so Minecraft, obviously, there's a chance to play here, but it's purposeful play, I think, that we have to keep in mind. So while the students are enjoying the experience and enjoy working at it, they're also doing it with a purpose in mind. So I talk to my students very much about the very fact that if we're going to be allowed to use a game in class, then we have to show that we're going to use it in a meaningful way. We're not going to be playing, we're not going to be building a house with TNT and then exploding it. We're not going to, drop lava onto someone else's build and burn everything down. It is very important that the students talk beforehand about being good citizens in the classroom and using the tool in a meaningful way. So if you talk to the students beforehand and set them up for success, then they usually do better with the tool. What my class did, when we were, this is for a server where we were working with students in a remote area, but it's also for your own classroom. So these were rules that we talked about so that they would be successful. So using their own name, so if they're creating a world, they would use their name, and they would not go into someone else's world. So it was very easy to see if they had gone into someone else's world. And then there's no real excuse for that. So talking to them about how that's not being respectful, they can create multiple worlds on a device. Griefing is something students understand. You might not have heard of it. Griefing means destroying someone else's build. And spamming would be when they start dropping a whole bunch of one type of creature into one place, which can be very problematic for someone who's working there. One of the important things that I should tell you is that when I started using Minecraft in my classroom, I had no idea what griefing or spamming was. And the very fact that I could talk with students and have them really genuinely talk about what was important to remember, they gave me the things that I didn't know. And they talked about it, and they genuinely wanted to use the tool, so they thought about it very carefully. Have students ever moved the concept of griefing to snowboards in the winter? That's a great question. last year we went out and we have white tubs in our classroom that make those kind of blocks, and we did build with what we called Minecraft snow blocks. We did build forts and all sorts of things outside. I can tell you the students in my class didn't break any of those, but I couldn't promise that no one else did. Building close to the spawn point, that's another important one, because wherever their character spawns in the worlds are fairly large. So you don't want them to fly for 5 minutes. You'll always have that student that enjoys the scenic route. They might take a little longer to do a lot of things. So just reminding them that wherever they spawn, that's where they should do their work. Build in your area unless invited by others to join them. So that's more on the server, but if students are sharing a space, you want to make sure that they respect each other's area that they're working in. There is a chat function in Minecraft, and if students are using that, if they're able to share on devices, then it's always about being positive, being polite, and thinking about what they're saying. No attacking other players. On creative, that's not really an issue. No entering others' builds without permission. That's the respect piece again. And the destructive materials usually doesn't come up when you're working with math, but if it does, then asking them to be respectful, and they can tell you which ones are destructive, and which ones aren't. Do all the students have their own device, or do you have school devices for those who don't? That's a great question, Heather. I have 8 iPads in my room that are devices that are shared between the students. I have Bring Your Own Device, BYOD, which I do at the beginning of the year. Students sign a form that they're responsible for their device, and they can bring it in. But when we work in Minecraft, I actually prefer the students to work with a partner. One-to-one using Pocket Edition. Nice, Joe. In my class, I prefer the students to work with a partner. And what they do is one person's sitting there with a whiteboard or a big piece of paper that has lots of room on it. The other student is on the iPad. And so whatever the challenge is, whatever it is that they're expected to do, whether it's doing a little bit of research to show it in Minecraft, or they're figuring out some math and putting ideas together for the math problem they've been given, one student is recording some things or figuring it out on paper. The other student is building it, sharing it, and showing it in Minecraft. They switch off every few minutes and take turns at both roles, and that way they're working with a partner. They're thinking about that collaborative piece, and they're taking equal responsibility for both the math that they're working on and showing the math in Minecraft. So if you set the students up with all of this beforehand, I've had great success, and I almost never walk past and see a student just being silly, like going around hunting zombies. There's a lot of silly things they can do, but definitely you want to have them showing their good job. I told them, I said at any time, if the principal were ever to walk in the room, I should feel completely comfortable that you're working on Minecraft because I know you're doing good and purposeful things. So we have to watch short videos tonight, and I apologize for that, but it's not possible with the technology we're using to share the screen on an iPad and show you what is happening. Every time there's movement, it breaks up. So the short videos are just so that you can see examples from Minecraft, and then we can discuss it when we come back to the main room here. The next video is about addition in Minecraft, and there's just some different examples here. So when you come back to the main room, if you want to talk about if one of those ideas would work in your classroom, that would be great. So the video is fairly short. The video is 2 minutes and 30 seconds. So I would hope 3 minutes from now we could all meet back here and get back to the conversation. Thank you. I'm seeing check marks, but people are back. Just a reminder to please hit the green check mark when you're in. And just your thoughts. Was there anything there that resonated with you? I'm trying to deliver this to anyone from grade 1 to grade 6, so there's a lot of different options there, but some of it was easier, but can you see how you could extrapolate it out to the older grades as well? Amanda, that's coming up soon. Okay, so addition is something that with younger students, it's a great way to dip in because we don't necessarily have to use numbers and they know their blocks really well. In fact, students can pick up blocks even when they're not visible. Some of the blocks blend together. As we finish grade 3 and get into junior opportunities to use arrays, definitely, absolutely. So I recently did fractions with my students and I tried to trick them by using wool blocks which blend together so that they couldn't tell how many blocks were in. And the fact was the blocks were blended together, but the students were so used to the size of the blocks they were immediately able to tell exactly how many blocks were in the design. So that was very interesting to me. So they're subitizing without even realizing they're doing it. Okay, did I set up the problem? For the students, what I did was I initiated the fraction one by showing them images that I built in Minecraft and just asking them what part of it seemed to be blue and what part of it seemed to be red. And as I can't remember what the exact colors were, but let's just say blue and red. And as they were looking at the colors, they were trying to figure out what the fraction was. I didn't mention fractions, but they started talking in fractions. And what I did after that was then I moved to the multiple blocks to show fractions as well. So they were starting to think about the fact that 3/12 is the same as 1/4. And so as they started to do that, they themselves were going into Minecraft and building the different fractions. So I said, how many different ways could you show me 1/4? So then they would use different amounts of blocks to show it. And so then we could discuss 1/4 of something can be a bigger number or it can be just 1 out of 4 things. So if you want to start with an example in Minecraft, but it's also not too scary to give students the opportunity to show you something as well. So if they have a concept that you're learning in class, you could just ask the question, does anyone want to show an example of this in Minecraft? And give them an opportunity to show you what they can do. So I looked at the math processes and I tried to think about which ones best fit Minecraft. And so I'm going to talk about that just for a couple of minutes. Problem solving is such a huge one and so important for us with students to get them to think about. And what I think we're all trying to overcome often is that negative mindset or that mindset students have that sometimes they just can't do math. And I've been reading Mathematical Mindsets by Joe Bowler, and something that really stuck out for me is that students with a growth mindset outperform those with a fixed mindset about mathematics every single time. And the key for students is to give them that feeling that they can be successful and that it's not just going down one narrow tunnel to get that one correct answer. And I think Minecraft is useful for that because when we give them a problem and give them multiple ways to attack or try to solve that problem, then they have multiple ways to come at it and they can see there's different ways of solving the problem, not one way, and they can also come to the correct answer in different ways. And Minecraft is one of the ways that they can do that. For some students that are very visual, this can be very helpful. So what I like about Minecraft is just the very fact they can spread out in the world. Sometimes we give them a piece of paper and they run out of room and they don't know where to put things. So in Minecraft, there's just so much space for them to work. It's easy for them to revise their model and their thinking. So instead of getting locked into one way of finding a solution to the problem, it's super easy to break up blocks. It's super easy to just abandon something you've been working on in Minecraft, slide over, about 20 meters in the world and start over again. So they're much more likely to do that with something like Minecraft, where it's just so easy to smash blocks and fix things. They're not erasing on paper. They're not scratching things out. It lends itself to that growth mindset and that opportunity to just try different things. Reasoning and proving. When students are reasoning through something, that partner piece really works well, where there's two of them, and they start by talking to each other about how they're solving the problem, and then they meet up with another group and they work on convincing the other group that their solution makes sense. And it doesn't always work, but everyone's open to each other's ideas, and then that group will be pitching their idea to the group that just shared as well. So in doing this, all the students have to talk about the math they did, and they have to communicate their thinking. So as they try to prove that what they've done makes sense and is logical, they can easily slip back in and change things quickly if it's not working, so that before they're finished their work completely, they can check in with it. Going to show you a student who took a challenge in my class. This is a short video, and I gave students that were finished their work early in class the opportunity to do something that I thought would be very tricky for them. I said, okay, if you finish your work early, you're more than welcome to go into Minecraft and see if you can build a working clock. And so they had different ways of trying this, and this student here, he jumped in and this is what he attempted. So if you want to watch the short video, it's about 33 seconds long. Thank you, Susan. Okay, so he is a smart kid, and the funny thing is, at the beginning of the year, he didn't have that same mentality where he'd jump in and take challenges. He was very nervous to try things and to show his thinking in the classroom, and he changed so much that year, and Minecraft was a big piece of that. He had a lot of anxiety about writing things down and recording his work because he was always worried about how it would be taken. So he really grew, and his love of Minecraft was one of the things that really helped him to come out of that shell. The download Minecraft. This is, the school has a account, and so we purchased it through the school account. I believe it's about $10 now, and it's not a small chunk of money, but at the same time, it's cheaper than buying the computer version. There's advantages to the computer version as well, but in the classroom, we're limited in the types of computers we have. It does not run on Chromebooks. It is easier and cheaper to use it on iPads. Oh, thanks, Joe. Yes, it is $9.99. Okay. Works on Samsung, yes. Works on Android tablets perfectly. That's what my daughter uses. It's $9.99 per device, yes. A lot of the students in your class can bring it in on their devices if you're comfortable with that and work with it in class. So if we could move on through the processes, then reflecting is a huge one. So use technology to explore, gather, display, manipulate, present data. So obviously they're using a manipulator when they use Minecraft, and their understanding of new concepts or new ideas, using a familiar tool, it's really helpful. The mental arithmetic or paper and pencil calculations, oftentimes it's more useful for them to do something on paper. And at first they always want to do it on a device, so they're always wanting to do it in Minecraft. But as the year goes on, we discuss it and we talk about it, and they come to the conclusion that sometimes it's just better to use paper and pencil or a whiteboard and a whiteboard marker to do the calculations. And so as they come to that realization, they start to understand and they're able to choose when it's a better tool for the task, which is really important for them to see. Also, when they do their work, when they're reflecting on their work, they are putting the screenshots from Minecraft into another app on the devices that they can type on. So they'll put their thinking right on the screenshot, which they can turn into me or share with me. And sometimes they do it live. When they're on their device, they come up to the front of the class, they plug into the projector, and they take the class on a tour through whatever build or whatever design they've made to show their math. Applying math to context outside of the mathematics. So when they're connecting their math to the outside world, you'll see an example of this in the patternings coming up. But we want them to think about the real world. And Minecraft, while it's very blocky and 16-bit-ish, is very much like the real world. So there's a lot of ways that they can connect to the real world and math that's in the real world when they're building in Minecraft. One of the times I had students doing area, the students asked if they could show area inside a house. So, oh sorry, Charlotte, I'm just noticing your question. When they don't sign in, is their work and world saved? Yes, it's always saved. As soon as they exit the world, anything they've done is saved in that world. So that's okay, don't apologize. So everything is saved in there and they can go back to it. I haven't really had students lose their work too often. Recording the screen while students are working on it. There's not an easy way to do this, but if you have a Mac computer, I know that you can plug a wire, the lightning cord into your computer and into the iPad, and using QuickTime, you can record everything that's happening on the screen. So in that way, you could record everything the students are doing. What I often do in class, because I don't have time for that, is I literally just take my phone and I record what they were doing on the screen of their device. Okay, I'll move on from connecting. Representing their work. So there's just various ways that they can represent their work. And in Minecraft especially, each student will have an independent way of looking at how they do it. And there's so many different things that they can use, so you'll get a lot of different ways of solving a problem. And that's really neat because the students get to see the way that other students shared their work. And rather than having 20 students in your class, maybe 5 of them are paying close attention, another 5 are half paying attention, and then the other 10 are becoming disengaged. You have an entire class leaning forward in their seats because they're totally blown away by what a student has done, and they just find it super exciting. It's really neat. This is another student, same class, same time, and he did something completely different. And if you could watch this video, it's just under 2 minutes long. What I'd like to discuss is, how do you think these two are different, and where's the value in how they are different and how their thinking was different in creating a working clock? Thank you. Okay, I'm seeing quite a few people back. Just to reiterate, you can record the screen on an iPad with a Mac computer, and you can plug the lightning cord into your computer and use QuickTime, which is free. It's on the Mac computer. If you don't have access to a Mac computer, there are apps that you can use on a Windows device as well, but I apologize, I don't know which would be best for that. There are some apps like Reflector that work, but I've never heard great results. I think you're usually better to plug in directly if you can. So both those students, they did come up with a design. A smart notebook record tool will get choppy. Troy, I apologize, I don't know about that. Maybe someone else could jump in if you know the answer to that. So, just you saw that student there. There was a lot of critical thinking that went into the design of his sand clock. And as he built that, just the very way that he had the sand break up at the bottom, everything he did, he thought through the plan, and he had planned it all out before he started. So he was able to share all of his thinking as he did it. And it wasn't necessarily as accurate or as much a working clock as the other students, but I still thought it was very valuable because of all the work he put into it. I'm going to move on here just for time. So again, communicating their work, what I focus on for communicating with the students is to have them think about what language they should use. So all the correct language that they're learning, we're doing transformations right now. So when they share those, I do have them explain that it's a reflection or a translation or a rotation. I try to have them think about the math and not just what they're building in Minecraft, so that their focus is the mathematics. And the big piece for me is that they're organized in how they're explaining their thinking. So they practice before they come up to the class, working with that other group, explaining their thinking, refining it before they come up to argue and prove that their way works. I do have another video here. This is patterning, and I tried to think of examples of patterning from grade 1, hopefully through to the older grades as well. So I hope there's something in here that you find useful. After you watch the video, if you just want to touch on something that you thought was useful or interesting in the video, that would be great. This is patterning in Minecraft. Okay, I'm seeing checkmark starting to come back. I'm not sure of the pronunciation. Is it C-Mac? Just so the logistics of it, I know exactly what you're talking about. It was a scary step for me as well to start thinking about. I think sometimes the best way is to start small and try something out before you go big. And that's what I did. So it started with one student asking to share work in class. I opened it up to that student, gave him the opportunity, and then slowly, as it was effective and was working in my classroom, I just opened the doors a little more and a little more as time went by and gave more opportunities. But it is definitely something that could be walked through, because there is a lot to setting it up and doing it properly, and there's different ways of doing it as well. So how many people saw something useful in the patterning video? Was there something that resonated with you at all? If you could write in the chat, that would be great. Yes, you can do graphing, absolutely. Patterns in the real world, yes, definitely. Pictograms, excellent. So in a grade 5 or 6 class, Fibonacci sequence, like taking that concept and then trying to move forward with that, the students can really start to see things that happen in nature and then finding other natural patterns and bringing them in. Recursive patterns, yes. Oftentimes on paper, it's hard for students to show three-dimensional patterns, but it's just naturally a part of doing things in Minecraft, and they can really see volume. So when they're doing things in 3 dimensions, and if they use blocks that they can see through, then they can literally see right through and everything that's happening. Okay. So, okay, that's good information too, Garrett. Thank you. So allow your students to be creative as they share, and it will spark ideas, and understanding will grow. And the biggest part for me is it doesn't end up the same way it started in class. I might have an idea of how I think something's going to go, and I start off with that idea in mind, and it might even be a simple thing sometimes. But then the students, as they create and they build things, they start to get really good ideas, and often a mini lesson will pop up beyond what I started to do with in the math class in the beginning. So we'll start to look at bigger things like the fact that 12/24 is 1/2, or 2/4, they're all related. Or we can do a pattern with growing numbers that are all the exact same fraction. These things will just naturally start to branch off as you go, and it's really neat to have the students so excited about it. And as it happens, you can jump into that example and teach that mini lesson and just go with their interest that pops up at that time. So it's really neat. Sometimes things happen that you might not have expected at the beginning of the lesson. So there's a lot of great opportunities that arise from it. And yes, definitely lots of art applications too as well. 8 iPads, Chris, what we do, we have 2 students to a device, and then if 1 or 2 students bring in a device as well, then we have enough for everyone to use them. This again, sorry, but another short video. This is multiplication strategies in Minecraft. It's a short video again. It's 3 minutes and 8 seconds. So if you could please watch the video, and then when you come back, just think of how you could possibly show Minecraft multiplication in your classroom. Okay, I'm seeing many people coming back into the room. Thank you very much for putting the check mark. Building a house multiplication, yes. And Amanda, I like to start with a problem in my math class at the beginning of a unit before I tell them what the math is we're going to be learning or doing. And we always kind of come back to it at the end. So we might think about building something at the beginning with multiplication, and then coming back to it at the end. It could be right in Minecraft where they do it. Yes, rows and columns, very important for the students to start to see. To set up a problem like that takes usually, a student could probably do it in under a minute. It takes me probably a minute and a half to do. I'm not as fast as them, and I sometimes misplace a block. Repeated addition, yes. And that's what we really want to do is once we start grouping those together and pushing them together, that's where they start to genuinely see that the multiplying actually helps. So the idea of building the house, what I thought was really, really cool about this was having the students look at the math. They would start to notice, oh, okay, I see there's 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. Well, that's easy. That's 25. I know that. It's like, okay. And then the students would also say, and then I've got 2 rows of 5 right here and another 5 rows of 5. So, oh, I'm not writing on the tool on the screen. These are slides that I made. Sorry, these are slides that I made. I wish I was that fast. So this I did on the Mac with just with the preview screen, but you can do it. There's a ton of applications. You can do this in Google Drawing as well. If you have Google Apps for Education, taking the screenshots, and there's apps on the iPads as well. We usually use Sketch, but you could also use. There's a lot. Like Pic Collage is another one that students use sometimes. So this problem here, the students, you know, they said, okay, well, we've got 5 times 5 and 2 times 5 and 5 times 5. I say, okay, great. And then they say, all right, so I'm going to write that out for people and show them. I said, that's wonderful. I can see everything you're doing there. But I have a question for you. What if someone says, oh, okay, 5 times 5 plus 2, well, that's 5 plus 2 is 7, so 5 times 7, 35 times 5, and then they start multiplying 35 times 5. And students were in a panic. No, that's not what I want them to do. And I said, okay, so I've got an idea. What if maybe we could put like brackets around those numbers, the multiplication numbers, so they know to do those first. So we were experiencing a need for bedness. So instead of having to learn what that is and then try to memorize it and then go off and use it, through the experiential learning of just finding a need for it while we were doing it in Minecraft, suddenly it became very valid, it became very valuable to them, and something that they had no problem understanding because they needed to use it. So this was really neat for them, that they saw a genuine use for this. So as they put the multiplication of their house together, they wanted to make sure that someone would be able to put all those numbers together properly. And that's the joy of using something like Minecraft that they're familiar with, is that you can then take those bigger math concepts and introduce them through this tool. I don't know all the ways to use Minecraft. I couldn't possibly know that because there are so many tools and the updates. Every time an update comes out, the students come in all excited and they'll tell me about these new things they can do. And I say, that's great, you can ride a horse, or a while back it was you can go fishing, that's great. And then in back of my mind I was always thinking, ratio, could we use fishing for ratio? And I'd try to think of how it comes back to the proper way of doing it. Command blocks in Pocket Edition? Okay. Not for tonight, but wow, that's pretty exciting. With the area model you demonstrated, able to take Minecraft character walking around the shape to demonstrate perimeter? Absolutely. You can walk around and do a tour. In creative mode, you can fly. So you can fly your character around and see everything that's happening as you go, which is great. And it allows them to walk through and see everything. I find for perimeter sometimes, it's great for the students. They'll drop an extra block every 5 blocks. They'll drop an extra block beside the perimeter so it's quick to count. So they can count quickly by 5s. They do this naturally just to make it easier to check perimeter quickly, especially if they're making a square that's quite large and they want to make sure that everything is in proportion. Again, not knowing everything about Minecraft, I was talking to my daughter, she's 8 years old, and she loves Minecraft, and I said to her, I said, I was just working on showing multiplication to teachers for Minecraft. And what she did was she said, well, Daddy, I was just doing that this morning. I said, what? She goes, yeah, I was doing that this morning, with Ender chests. And I said, of course you were. And I don't actually know what Ender chests do because I never used chests. And she explained it to me, and I thought it was pretty cool. So if you want to, take a look now at this short video. It's a minute and 40, or about a minute and a half, and this is her first time doing a video, so I thought she did a pretty good job. Thank you. I think one of the big values in what I showed you with my daughter is that it's important to let the students show you things as well. It's never the best thing to stand at the front and say, I know everything about this, this is how we're going to do it. the more freedom you give them, the more neat ideas they'll come up with. I'm seeing most people are back, so I'm going to move on just for time. And I see 25 check marks. Is everybody back at this point? Yes, flexible thinking, Jennifer, definitely. And I think if we want our students to show a growth mindset as teachers, we have to be willing to do the same. We have to be willing to grow and to learn and to try different things as well. So I'm just going to move on and show a different example of a problem in Minecraft. This was another problem I gave my class. And what I said to them was, I said, there's something wrong with these quadrilaterals. I want a diagonal line to go corner to corner. Can you build quadrilaterals that work? So what the students did was they had to figure out why this wasn't working. And I thought it would take them longer than it did. It really didn't take them very long to figure out. And they pretty quickly came and said, Mr. Mack, the problem is it's not a square. It has to be a square. All the sides have to be equal. But then I threw it back at them and I said, well, why does it have to be equal? And so that gave them pause, and they went back and they thought about it again, and they came back and they figured out independently that the area inside each side of that diagonal line was exactly the same if it was a square. And if each side, the area was exactly the same, then it was equal and the diagonal line would go corner to corner. And what's really cool about that is they're basically figuring out how to figure out the area of a triangle, even though they're grade 3 students. So I thought that was really neat. So with an older grade, I would introduce the problem without talking about the squares or the diagonals, and I would say, how can building squares in Minecraft help to figure out the area of a right angle triangle? How about an equilateral triangle? And the neat thing is, I do give them things that aren't necessarily possible to do. So an equilateral triangle, we're not going to find that at least with a square. So it's not that it's necessarily going to be a positive result, but by working with the tool, especially a tool they enjoy using, they're willing to try it out, and hopefully they can then prove that it does or doesn't work and show examples. An important thing to think about when you're doing Minecraft, the blocks themselves have a thickness to them because they're three-dimensional. So sometimes we have to agree as a class that we're just going to look top-down, bird's eye view, and recognize those blocks as two-dimensional squares. And when we do that, that allows us to think about it as a two-dimensional piece of work as opposed to a three-dimensional piece of work. Also, when you're doing perimeter and area, if you're doing the area inside this square, you also have to do the perimeter inside the square as well to allow for an accurate result. So because of the thickness of the blocks, we do have to discuss that and talk about it with our class before we start. So here's a way to show better the triangle. If you use some of the smaller materials that are available in Minecraft, these are torches, and the torches allow it to basically draw a triangle properly because those are not blocks. How many triangles can you find the area for with Minecraft? How can you explain your answer clearly? So with students, this question is fairly open because I'm not telling them which types of triangles are easy to find and which aren't. And as they build the one side bigger or they build the square bigger, they'll quickly find out what works and what doesn't work. So it's a guess and check mentality, but it also will quickly start to show up a pattern for the students as well. So working through guess and check, they'll also start to see the pattern and be able to build on the pattern. And if you're in the older grade, you can talk about what the equation might be as well as you start to talk about that. Students will start to naturally use different tools and strands when creating in Minecraft. So they might have area, perimeter, volume, just so many different things. They're multiplying, they're doing a whole bunch of things all at once when they're working on one project. And the key as a teacher is to step in and say, I see that you're doing this. What other types of math are you showing right now? What other math can you find in what you're doing? This is students in my class. Recently, when we were doing fractions, they had created their fraction, and I said, how do you know that your fraction is correct? How do you know? And it's a little hard to see in this image, but so here's their whiteboard, and so they showed, okay, I can add up. It was 18s. I can add up the 18s, and they add up to 54. I said, okay. And then they showed the multiplication here as well, and they did their arrays. But then she also came over here, and right on the, I'm hoping you are seeing a green triangle on the screen right now, but they also went over here, and she did one side multiplication, but then on the other side, she overlapped and did the other number. So she was able to count up how many rows there were and how many columns there were, and she multiplied right on the screen in Minecraft using multiplication to check that her fraction was accurate. And I was just super impressed with how she let all of that come together, and it was very natural. There was nothing forced. They get used to doing it, and it's not even a challenge. They just see how the different math relates to each other. Yeah, it would be a fantastic math manipulative, and you'd probably get students trying to come back in grade 4 to do it again and again, EQAO. It would be a lot more popular, wouldn't it? I'm worried that they're going to give an example, a Minecraft example on the grade 3 test, and no one's going to know what it is. This is a super short video, just a challenge to my students at the beginning of the unit on transformations, and I said, hey, how could you show me transformations in Minecraft real quick? And so this is a short video if you want to just watch. It's only about 30 seconds. Thank you. Okay, I see people coming back in. This is just another example. So same idea, transformations, and the option was for students to build a roller coaster that shows all the transformations. And here there is a 3/4 turn, there's a reflection that happens, there's rotations. There's obviously the slides are happening. So all of this is happening here, and it happens in a closed course. And so that's with mine carts and with powered rails. I'm just cognizant of time, so I'm going to keep going. If you have any questions, just please pop them up in the chat. So here's another question you could give your students. Build a pyramid that includes fractions, growing patterns, and a division problem for other students to solve. So here the students are creating the problem and they're sharing it with others. So if you were consolidating student learning and wanting them to think about some different things they've been learning, especially if you're doing recursive math and you're coming back to some learning you've been doing earlier in the year, here's an opportunity to have them show their understanding, and they'll start to see the relationship between the strands of math, which is super important. If you have younger students and you want to talk about location on a grid, here you can walk the students through this. You can physically build it in the classroom and have them walk through it after they've designed it in Minecraft. And they can take another app and they can draw the straight lines on and physically draw the path through so that they can figure it out. Another question you could ask students: build a maze that teaches someone how to use the XY grid system and has them apply those skills to navigate the maze. You could have older students design this for a younger class, and then they could take it to the younger class and help the students to work their way through it. This was something that I saw in Joe Bowler's research, and it was very interesting. So in this pattern, what would come next? And imagine that this pattern is representing the number of blocks. So it starts with 4, and work your way through. And what would be the next block in this pattern? I'm sorry I'm making you do math at 8:53 in the evening, but if you want to quickly check. Joe, you're quick. Any other answers before I hit the next slide? Interesting. Okay. One of the powerful things with Minecraft is the very fact that it's very quick and easy to rearrange the blocks. In this pattern, sometimes we have to think about how we see the new blocks added on. And some people see them coming in above the first blocks like this. Yes, and it is so cool to see how they see the pattern coming. Some people see it building outwards. Some people see it building underneath each time that it's building under the original. But what I can do with the blocks so quickly is I can just rearrange those blocks underneath so that I can quickly add up exactly how many blocks are in each one. So I have a 2 by 2, a 3 by 3, a 4 by 4, and then the next will be 5 by 5. And so we're showing students how to visually think about the numbers, which is a really neat concept. And taking it further, and I know it's getting later, but taking it a little further, so if I can show that here's the original, but how are we adding on those new blocks? So, okay, you can see them here, and then the mystery blue block. So how does this visual help to explain the algebraic expression n plus 1 squared? Because that does explain this pattern. And I was having a bit of trouble with this because it's a bit beyond me in grade 3, but I was very interested in it. So I was thinking about it, and I had a high school math teacher friend, and I showed this image to her. And it was really interesting. We were both looking at the blue block for a bit, and then finally she came back and she said, okay, here's why it makes sense. And so we worked through it again, and it's 1 times 1. So when we multiply 2 times 2, and we double that, that makes sense. but it's the 1 that's left over, the 1 times the 1, which equals 1, which is the blue block. And she loved this so much, she said she was going to use this with her high school class to introduce this. So I thought that was kind of neat. But it's just very interesting how the math makes more sense when we can use something visual with the colors and the blocks in Minecraft. Just a little aside, I was trying to find the little squared symbol and having trouble, and I found this website. So I just threw this in here because I'm sure most of you already know it, but if you don't, you can find just about any mathematical symbol on this website, and you type in the right code, or you copy it and you can paste it in, and it's really great to have. Okay, we're almost out of time. So here's another pattern, and this pattern here grows each time. And it's volume, so you're introducing that concept to grade 5 and grade 6 students. We're talking about volume. And it's very easy for them to see. And if you want them to understand cubed, they can visually see 3 blocks on one side, 3 blocks on the other side, and 3 blocks moving upwards. Sometimes I give them a question that can't be answered, that maybe the Greeks spend a lot of time thinking about. Failure leads to success, and more importantly, to understanding. So one question you could ask your students is, can you build a cube with twice the volume of this one? Justify your answer. And students could puzzle at this, and it was something that the ancient mathematicians spent a lot of time trying to figure out the answer to, but at the end of the day, you can't. But hopefully the students will start to understand volume and the idea of cubed better, because it's building in 3 different ways, so you can't double it. And so as they work through the problem, because they're building in Minecraft and they can quickly break it down and check it again, they really start to understand this concept. These are just example questions. I know I'm almost out of time, Susan. Here's another one that's interesting for you. In Minecraft, every single block that's a proper block size has exactly the same amount of small pixelated blocks in it. So it's 16 by 16, and that's on purpose. So you can figure out the area or the volume on any face, the surface area. You can do a lot, even just one block in Minecraft, having the students figure that out. And with an older class, then you can have them figure out each individual block in a bigger one, especially if they're quicker with their math. They can start to think about the big numbers. More questions. Build 3 different rectangular prisms with 600 blocks of volume. How do they differ? So there's multiplication happening here. They're working on volume, thinking about area, all sorts of things. Perimeter and how they talk about how they differ. We won't watch this video for time, but I'm sure the link will be in at the end when Susan puts everything together. So this is just ratio, and it's a sheep, and the sheep eats the grass, which is really cool. And I've penned the sheep off so it can't jump out and escape, but it's also raining. So the rain replenishes the grass, and the sheep eats the grass. So there's a really neat thing happening where you've got multiple ratios happening at the same time. So you could start to do your data, and there's just so many different ways that that could play out in your classroom depending on your grade. Yes, Christine, my hope was that people would see that there are multiple ways Minecraft can be used, so that's awesome that you're noticing that. You could ask the student, what's another way to show ratio? And then completely open-ended, build a math world that has challenges from 5 different types of math we have learned this year. So if you want a really interesting consolidation at the end of the year for your students, my students tried to build a Prodigy-style world with questions. And if they got so they can use redstone, which is electric, and then if they go up to something and they get the question wrong, then it trips and they fall through the world and die. and then they have to come back in and they have to try again. And there's so many neat ideas they came up with, and it was really cool to see. I'm sorry for going a minute over. Thank you everyone so much, and thank you.
Okay, that was amazing. So you just go all ahead and put a little happy face or a little symbol. Sorry, Scott, I'm going to zoom ahead to my next slide. Yeah, just keep putting your comments in there, and I'll do some of the boring stuff. So, Scott, that was awesome. Thank you very much. Garrett from PB Jelly Games on Twitter was also with us tonight as an attendee, but thank you, Garrett, for coming and for promoting and tweeting and answering some of the questions in there. We really appreciate that. Scott, I think one of the things you were hoping to do tonight was to get people excited about the potential of using Minecraft in education, particularly in math, and wow, you succeeded. That was fantastic, really wonderful. I have just posted into the chat 3 links. One of them is to a feedback survey, and particularly since Scott's a new presenter, take a few minutes and do that, please. It helps at this time of year. I know that Syria, who's the coordinator of OTF Connect, is starting to put together ideas for next year, and we'd love to have Scott back, so we can do that with your help. There's also a link in there to a feedback or a certificate that you can print if you're still gathering paper things for a professional portfolio. And to the, I think there's a link there for the calendar for OTF Connect, because there are still a few sessions left in April, and I think maybe the first week in May. And then we finish off for the season. So I'm actually going to stop the recording, and I'll say a couple more things, and then I'll let Scott finish up if he's got anything to say or questions to answer. So once again, thank you all of you, and a huge thanks to you, Scott.